Hi everyone, this is a video over special right triangles, and so we're wrapping up the last little bit of our Unit 5. We've reviewed Pythagorean theorem, and we've talked about trig, which was the sine, cosine, tangent, and so this is another way for us to solve for missing pieces of right triangles. So there are two special kinds of right triangles. We have a 45, 45, 90 and a 30, 60, 90. And what that means is that we have, for the 45, 45, 90, you have a 45 angle, a 45 degree angle, and a 90 degree. And then for the 30, 60, 90, it is 30, 60, and 90. Okay, let's dive into the 45, 45, 90 first. Okay, so for the 45, 45, 90, notice that you have two legs. We've talked about this previously. The legs are the sides of our triangle that create that right angle, okay? So you have a leg and a leg, okay? Those two pieces create that right angle. And we just call those leg and leg, okay? Notice that their value is x. That's because if you have those two angles that are the same, the two legs are going to be the same because it's an isosceles triangle. So notice if this leg is 5, or if this leg is x, then this leg would be x as well, okay? The hypotenuse will always be the x square root of 2. So here's what let me show you an example of what I'm talking about. Like if this leg were a length of 5, okay? So that is this 45 degree angle opens up to a side of 5. So underneath 45, I would put a 5 because a 45 degree angle opens up to a length of 5. So that tells me that x is equal to 5. So everywhere I see x, I'm going to put a 5. So this x would be 5, and this x would be 5, but then it would be square root of 2. There's the side lengths of my triangle. The sides are 5, 5, and then the hypotenuse is 5 square root of 2. Let's look at an example. So find the value of the missing sides. I know that this is going to be a 45, 45, 90 because I have a 90 degree and then I have the 45. So remember, all the angles of a triangle add up to 180. So this angle will be 45 as well. Okay. So I need to look at the side that I know, and I know that this one is the side that I'm given. The angle that opens up to him is that 45. So 45 goes with 11. So underneath 45 over here, I'm going to put 11. Now, it doesn't matter which one I put the 11 under. I could put it under this 45 or this one. Remember, they are the same. Now that I put the 11 underneath the x, I know that x is 11. So everywhere I see an x, I'll put 11. So that tells me that the other leg is 11, and then the hypotenuse would be 11 square root of 2. Because notice, underneath the hypotenuse is that 11 square root of 2. Okay, so what is the value of x? Okay, so let's see. I'm given this side. That's one of my legs. So underneath the leg of 45, I'm going to put 5 square root of 2. So that tells me that everywhere, remember that 45 goes to 5 square root of 2, everywhere I see an x, I'm putting 5 square root of 2. So the other leg would be 5 square root of 2. The hypotenuse, I'm going to put a 5 square root of 2 here, but then I also have this other square root of 2. So when I multiply these together, I end up getting 5 square root of 4. But let's think about this. What is the square root of 4? It's 2. So what happens is when you have square root of 2 times square root of 2, right here, that just becomes a 2. So you would have 5 times 2, which is 10. Let me show you another example of what I mean by the square root times square root. If I had square root of 5 times the square root of 5, that's just going to be 5. If I have the square root of 10 times the square root of 10, it just cancels out, becomes 10. Square root of 6 times the square root of 6 is just going to be 6, okay? So that's why when we do square root of 2 times square root of 2, it just turns to a regular old 2. So if I had 3 square root of 2 times the square root of 2, the square root of 2 times square root of 2 is going to become a regular 2, and I still have to multiply that by 3. So this would become 6. So our answer here, the hypotenuse, is going to be 10. Let's take a look at 30, 60, 90, okay? 30, 60, 90. So instead of having just two plain legs, we have a short leg and a long leg, okay? Notice that the 30-degree angle, that's the smaller angle, okay? He is opening up to the shorter leg or the smaller leg, okay? The larger, the 60 degrees opens up to the long leg. And then, of course, we have the hypotenuse. Okay, the ratios for the short or the 30, 60, 90 is x squared of 3, 2x. Okay, we're going to do the same process where we label our sides, short leg, long leg, hypotenuse, and we identify what side we're given. So let's look at an example. What is the value of x? So we're trying to find the value of this side here. Okay, so the 60 degrees opens up to him. Okay, so what side am I given? I am given the hypotenuse, or the 90 degree, right? So underneath the 90 degrees, I'm going to put, or the hypotenuse, I'm going to put a 7. So now we're kind of working backwards. We have to find what this x is in our picture, okay? Or our x is in our ratio. So we have 2x is equal to 7. If we divide by 2, x is equal to 3.5. So now everywhere I see an x, I'm going to put a 3.5. So the short leg will be 3.5. That is this piece right here. Remember, this is the short leg because it is opposite of the 30 degrees. Okay. For the long leg, I have 3.5 times the square root of 3. So this piece right here is 3.5 times the square root of 3. Now be careful because it did ask for the value of x. That for us, for this example here, that is the length of this side, okay? The x for that side is different from the x that's in our ratio, okay? Let's look at this other example. So it says the shorter leg of a 30, 60, 90 triangle is 4. Hey, you can draw a picture, and you guys know that I love when we draw up the pictures. I highly suggest that, okay? So the shorter leg is across from the 30, that is 4. So underneath 4, or underneath the 30 degrees, the short leg, I'm putting a 4. So now I know that x is equal to 4. So everywhere I see an x, I'm putting a 4. But you got to keep the other part with it, okay? This other one is 2 times x, so it'd be 2 times 4. And this would be 8. So it says, what is the length of the hypotenuse? Right here, which would be 8. Real quickly, I want to look at another example just because we're going to see these and I want to review square roots. Okay. Let's say that for our, let's just do 45, 45, 90 to keep it easy. Okay. You have x square root of 2. Okay, let's say that you are given a triangle and the hypotenuse is 10. Now, the hypotenuse was matched up to the 90 degree, right? So I'm putting a 10 underneath here. So what that means is we have x square root of 2 is equal to 10. Now remember whenever when I did this example here and I had the square root of 2 times square root of 2 became a 2, I need to do that again, but this time, it's just like I'm working backwards. So the square root of 2 here, I know that in order to go from something square root of 2 to a 10, we got rid of the square root, so we had to cancel them out. So I have another square root of 2. So remember, these turn into a 2. So what number, right here, what number times 2 would equal 10? It'd be a 5. So that doesn't, now be careful here, because that does not mean that x is equal to 5. It means 5 square root of 2 is equal to x. So each one of these sides is 5 square root of 2. The same thing would go if we had, let's see, the ratios of the 30, 60, 90. Let me grab those real quick. Let's say that they give us the length of a long leg and it is 12. Okay, that means that the x square root of 3 equals 12. So if we had a square root of 3 and it turned to a 12, like it got rid of the square root. So that means we're going to have a square root out here. But we're also going to have another number here. So square root of 3 times square root of 3 becomes just a regular old 3. So then what number would I put in here times 3 would equal 12? Well, we know our multiplication. We know there'd be a 4. So what that tells us is x is equal to 4 square root of 3. So the short leg would be 4 square root of 3. This one, the hypotenuse, would be 2 times 4 square root of 3. So the 2 just multiplies with the 4, making it 8 square root of 3. Okay, I know that might have been that was a lot of information, and you're just like, what did she just do in that? Hey, if special right triangles, if that doesn't make you comfortable, you can still apply the sine, cosine, tangent method to solve these. These are just shortcuts or ratio, like quick ratio patterns to solve these special right triangles, okay? And remember, the lesson is full of examples, so I highly suggest you going and watching or going through the lesson and doing the examples and not relying solely on this recording. Make sure you're going through the lesson, guys. Thanks a lot. Bye-bye.